the Edgerton, Germershausen, and Greer trailer from Cambridge, Massachusetts, the Armor Research Foundation trailer from Chicago, the Sandia van from Albuquerque, and the Navy Radiological Defense Laboratory trailer from San Francisco, all gathered at either the Naval Repair Facility dock area or at the Naval Air Station, North Island, prior to loading for the cruise to the operating site. One of the major reasons for the decision to use the large YFNBs as floating laboratories was to allow the trailer-mounted vans and project shacks containing recording equipment to be put aboard as completely integrated working units. It was essential that the full electronic story of event happenings be recorded on the surface in case we lost the Squaws as a result of the detonation. So many gauges installed in the engine and battery compartments inside the Squaws sent their signals through the cable bundles to the recording instruments aboard the YFNBs. Since the YFNBs would be stationed in the array relatively close to surface zero, it was decided to evacuate all personnel prior to H-hour and recover the recorded data as soon as possible after the event. In addition to the instrumentation located within the Squaws, a variety of gauges were installed at intervals on and from the various units of the array. On YFNBs and in M-boats, strings of gauges were prepared to go over the side several hours before the event. Full photographic coverage of the surface effects was provided by batteries of manned and unmanned cameras located on the command and support vessels, on the 3 YFNBs, in 3 specially modified C-54 aircraft, and inside the Squaws themselves. Some of the projects required permanently manned stations during the test, so their recording positions were stationed aboard the various task group ships. Early in May, and several days before D-Day, the first elements of the task group left port for the rendezvous area. A few days later, the faster ships left San Diego. Task Group 7.3 represented an interesting composite group of naval vessels, all having an essential part in the overall operation. The command ship, the USS Mount McKinley, and the weapons ship, the USS Curtis, were both veterans of other atomic tests. In addition, the Wigwam support family included the aircraft carrier USS Wright, with her complement of AD-5Ns and Marine helicopters to provide search and taxi service. The 2 LSDs that served as a haven in heavy weather for the School of Overworked M-boats, and the 2 YAGs supporting the radiological survey and washdown studies. Important missions were also assigned to fleet tugs, ASRs, ARSs, LSTs, and the group of 8 destroyers that formed the perimeter security guard. Wigwam air cover was furnished by the Navy air elements from San Diego and the Air Force photographic aircraft from Albuquerque. The major operational element of the task group, the array itself, was a strange-looking floating blast line with its weapon barge, its 3 squaw target units, and auxiliary craft. It was 30,000 feet long when finally assembled and in tow by a single fleet tug, the longest towed array in naval history. This practically perfect array line was assembled during the sea trials off the coast of San Clemente Island in January of 1955. We enjoyed nearly ideal weather conditions. However, in May, the story was different. The weather was far from ideal. In fact, it exceeded our most pessimistic expectations. At the identical stage of the actual operation, D-2, the final array looked like this. The wind increased to 15 knots, and the sea began to pile up. Weather already caused a 3-day postponement in our test schedule. We had already lost the supporting pontoons for Squaw 29, resulting in its final use as a surface target. Consequently, a readjustment of the positions of all targets was made to ensure an adequate bracketing of the lethal range with only 2 submerged targets. This resulted in a final planned positioning of targets at surface ranges of 5,400, 8,200, and 11,400 feet. D-1 brought no improvement. We experienced a steady wind of 20 knots with gusts to 24. Sea and swells were totaling 10 to 15 feet high. Submerging the 2 remaining squaws was much more difficult that day than on any of the previous trials. Ideally, the submergence operation worked like this. The squaw took on ballast until it settled stern heavy, clearing the pontoons, sinking to the length of its 4 chains, 250 feet, below the surface. The supporting pontoons were then positioned directly over the squaw. The severe wind and sea conditions caused considerable bending of the array between the inner and middle targets. The actual distances of the targets at the time of detonation were 5,200, 7,300, and 11,000 feet, respectively, from the weapon support barge. This uncontrolled modification of surface distances proved to be fortunate in that it resulted in the second target receiving severe but not fatal damage, an ideal position for the study of target response at incipient lethality. Our scientific test program was organized into 6 main areas of responsibility: radiological and oceanographic investigations, target response and hull damage mechanism, timed and untimed technical and report photography, timing, firing, and communication support, weapon procurement and placement and evaluation of its performance, and measurements of free field pressures and other transient underwater and surface investigations. Notice the cloud chamber effect and the focusing of the reflected shock wave. This latter phenomenon was caused by the local valleys and hills in the sea floor. In at least one area, 15,000 feet from zero, the water was strongly whitened, indicating pressures in the neighborhood of several hundred pounds per square inch, about that to be expected at 10,000 feet, and enough to cause the collapse of light-hulled submarine. At other places, the bottom reflected shock appeared to be missing completely. At the Mount McKinley, 5 miles from zero, the bottom reflected shock was several times as intense as the direct shock wave. The initial spray dome, caused by the arrival of the primary shock wave, reached a maximum height of 147 feet at 2.4 seconds after detonation. The second dome, formed at approximately 2.5 seconds, accompanied by individual plumes, reached a height of 800 feet in about 7 seconds. 2 well-defined plume formations occurred. The first plumes reaching a diameter of 3,100 feet and a maximum height of 1,410 feet, 19 seconds after detonation. The second well-defined plume reached a height of 770 feet, 38 seconds after detonation. The outfall and descent of the material in the several plumes resulted in a well-defined base surge, about 640 feet in height and extending outward about 4,800 feet. The great mass of water thrown into the air resulted in surface waves that were about 2.5 times the maximum height predicted. A well-defined breaking surface wave was first observed coming out of the base surge at about 1 minute. This quickly became stable. The YFNB-12, at a range of 5,500 feet, rose and fell a distance of 40 feet. This resulted in a product of range times height of 220,000. The maximum product predicted was 80,000. These waves were completely undetected at the task group elements at a range of 5 miles, except that they showed beautifully on one surface search radar, which was temporarily out of adjustment. It had been knocked out of service by the shock wave, and on being returned to service, the gain was set high, so that strong sea return, modulated by these waves, covered the scope face. About 15 waves were visible, with wavelengths ranging from 5,000 down to 900 feet. The maximum energy appeared to be in the 1,800-foot region. These waves could have serious implications in the case of detonation of thermonuclear weapons on or under the surface of deep water. The seismic shock was easily detected all over the world. The Coast and Geodetic Survey reported the shock as an earthquake at 1300 Pacific Daylight Time on 14 May, with an epicenter about 15 miles from surface zero. The most probable position of the shot has been determined by task force navigation to be 28 degrees 44 minutes north and 126 degrees 16 minutes west, with a probable error of 1 minute of arc. At H hour plus 8 to 10 minutes, the shock wave hit the mainland of Lower California. At H plus 10, the SOFAR equipment at Point Sur, California, received the first shock wave. At 1312 Pacific Daylight Time, a Greek ship just off the Golden Gate radioed the Coast Guard asking, "Has San Francisco just been hit by a severe earthquake? We have been badly shaken, but are all right and will return to render assistance if needed." At H plus 32 to 34 minutes, the Kaneohe station in Hawaii recorded the sound of the Wigwam detonation. And about 42 minutes later, Point Sur received a beautiful echo from the Hawaiian Islands. In fact, separate echoes from each of the islands in the group. Just to top the story, the Kaneohe station also recorded fine echoes from the California coast and from the Gulf of Alaska. The fallout and contamination resulting from the shot presented an ephemeral problem only. The major plumes were contaminated, but this material was present in a very large mass of water and for the most part returned to the ocean surface within a minute. No ship associated with the test received any accidental contamination. The converted Liberty ships, the YAG-39 and the YAG-40, transited the radioactive area. All transits were not completed as planned due to a long train of events triggered by minor shock damage to the YAG-39, which immobilized her for about 4 hours. At H plus 17 minutes, YAG-39 received a fallout reading of 400 Roentgens per hour, 5 miles from zero. An effective washdown system reduced this level to a maximum reading of 150 milliroentgens per hour on deck.